So thank you again to everyone for joining us for the Applied Machine Learning Conference here in Charlottesville. We're an independent event that is organized by and for data science and AI and machine learning researchers and practitioners, and we're delighted to have everyone here today. I would like to give one more thank you to our sponsors who have helped make the event possible: the University of Virginia School of Data Science, S&P Global, General Atomics Integrated Intelligence, the La Crosse AI Institute at the Darden School of Business, and Rotational Labs. Thank you to these organizations for financially supporting this event. Doing this kind of thing would not be possible without organizations like this helping us out to do things like renting out an entire cinema for a whole day. I'd encourage folks to check out the Applied Machine Learning Conference job board. This is a page on the website, and it features job openings from our sponsors, which range from entry-level positions up to the global head of data science for a Fortune 500 company. So if you're in the market or just interested to see what kind of jobs are out there, I would highly recommend checking out the job board. Finally, there are a few t-shirts that we noticed weren't picked up by people who purchased them. So if you purchased a t-shirt with your conference registration and you haven't picked it up yet, please stop by the front desk on your way out and give one of our volunteers your name, and we'll look up your ticket sale and get you your t-shirt. We have an official conference social event this year. It's immediately after this session. We will all, in, I assume, a large amoeba-like group, exit the cinema and turn right and walk 3 blocks down the downtown mall, 3 or so, plus or minus, until 3rd Street, and you'll turn right on 3rd Street. We're going to a venue called Vault, Virginia, which is a gallery and event space and co-working space in a converted bank building on the downtown mall here in Charlottesville. It's on the downtown mall at the corner with 3rd Street. We'll turn right on 3rd Street, and we'll use the side door to get in. There's signs both for Vault, Virginia, and I think we'll have signs for the Machine Learning Conference guiding you there. But we'd love for everyone to join us after the session right now for the social event at Vault, Virginia. On Saturday, this is a 2-day conference. For tomorrow, we will not be here. If you come here to this venue, you'll be able to see Project Hail Mary, but you won't find the tutorials and the lightning talks. Tomorrow we'll be over at this building, which is the University of Virginia School of Data Science, and we've got 12 in-depth tutorials as well as 10 lightning talks scheduled. And the lightning talks are 8-minute long talks. Many of them seem just as compelling to me as the talks that we had scheduled today, the full-length talks. And if you signed up for a Friday-only ticket, Saturday tickets are still available. If you came today and you think, wow, I would like more of that, but even more in-depth and interactive in a classroom setting, we've got that, got you covered tomorrow. So you can get tickets for that on the conference website. I also wanted to highlight one of our tutorial speakers. Amir is organizing an AI walk. This is for Sunday, and this is something that he's done in cities around the country for the local AI and machine learning and entrepreneurship community. It's independently organized. A bunch of AI researchers, practitioners, enthusiasts, and entrepreneurs get together and meet and walk and talk for an hour or two, get some fresh air, get some exercise, meet other interesting people, and then they all get lunch afterward. So this is if that sounds interesting to you, this is the link to the event. This isn't organized by our team. It's not an official part of the conference, but we're really glad that Amir took the initiative to organize this, and we would encourage you to check it out. I'll leave that up for a second. And he's over there in the crowd. Do you want to say hi? Yeah, so if you're interested, go talk to Amir after the session. I also wanted to highlight that we have a year-round data science, AI, and machine learning community here in Charlottesville. The Applied Machine Learning Conference is our big annual event, but every month we're doing events where we have sessions like the sessions here at the Applied Machine Learning Conference. So if you enjoyed your time today and you think, I would like more of that throughout the year, sign up for our mailing list. It's at news.cvilleds.org, and you'll be plugged into all of the community announcements and event updates for the data science, AI, and machine learning community here in Charlottesville. Outside of organizing conferences and helping lead the data science community here in Charlottesville, I run an independent data science and AI consulting business called Data Theoretic. I help organizations understand and think through modern data science and AI capabilities and how they might apply them in their organizations. And I can also connect clients with experts and with full-time employees who really know what they're doing and know how to execute on these kinds of projects. So if you saw anything at the conference today and you think, I would really like to explore that for my organization, I would like to learn more, please reach out to me. I'd love to have a conversation and to be able to help you with that. And finally, I'd like to say thank you to our Applied Machine Learning Conference organizing team and to all of our volunteers. Our organizing committee in particular is Kate Atwood, Zach Brown, Ryan Dallas, Alec Goss, Michael Holroyd, Sam Kunitz-Levy, Reggie Leonard, Katya Mastropas, Renee Teat, and Stephen Turner. So this has really been a team effort from the start with a bunch of people involved representing a bunch of different organizations, both in Charlottesville and across Virginia. So I wanted to say thank you to our whole organizing team for making this happen.
And thank you, Patrick.
And we also had a whole team of student volunteers, primarily from the UVA School of Data Science, but not only, that were helping us out today doing things like running the registration desk and other jobs around the conference that need to be done. So I wanted to say thank you to our volunteers too. And now I will get out of the way and hand things off to our closing keynote speaker for the day, Vicki Boykis. Vicki is a renowned machine learning engineer, and I've followed her work in writing for at least a decade now. I'm not sure how long. Vicki has previously held roles in machine learning and AI at organizations like Captech, Duo, Automatic, and Mozilla, and currently she serves as the founding ML engineer at Malachite. One thing I've always appreciated about Vicki's work is her focus on practical, everyday machine learning, on getting things done in production. And one perfect example of that is when she served as the lead organizer of NormConf, which was an entire conference focused on the real everyday problems that machine learning engineers face, not just what is the latest research that's getting all the hype, but how you actually get things done in your job at a real company, which I feel like it's great to shine a spotlight on those kinds of problems that don't often get published as papers or float to the top of Hacker News or anything like that. We're delighted that she agreed to share her current thinking and work here with us at the 2026 Applied Machine Learning Conference. So please join me in welcoming Vicki Boykis.
Okay. Thank you. All right. Let's get these slides going. Is it showing? Do I need to drag it? Oh, all right. Here we go. Yay. Can I do this backwards? Yeah, all right. Hey, everybody. How's everybody feeling? It's the end of the day. It's really nice out. It's really warm. I myself got drowsy, so I had a coffee. It's the end of the day. Hopefully, this will be a good and interesting talk. It's called Build Yourself Flowers. Thank you to everybody so far who has organized the conference. It's been, I don't want to jinx it, but today so far has been extremely smooth and a pleasure to be at. So I'm Vicki. I build machine learning systems. I was thinking about how to introduce myself. Oh, I should probably start my timer so I don't go over and keep everybody from Vault later on. All right. So I was thinking about how to introduce myself. And I used to introduce myself as a data scientist, as a machine learning engineer. Am I an AI engineer now? I really don't know. So I just say that I build machine learning systems. I have built and broken systems at all of these companies that were mentioned in the introduction, Tumblr Automatic, Dell, Mozilla AI. Right now, I build and break personalization in search systems at Malachite, which is a startup working on search and recommendations in e-commerce. And the 5-second plug is we are hiring. So if any of this stuff interests you or talking to me about flowers, please give our jobs a look. OK. So in introducing myself, I said that I was having kind of like an existential crisis. Am I a data scientist? Am I an ML engineer? Are we still even doing machine learning engineering? I think over the past 6 months, I felt a real vibe shift, and everybody I've talked to has felt a real vibe shift. Whether it's real or perceived or not, the mood has changed because over the winter, I was like, oh God, I don't know what I'm doing anymore. What does it mean to do work? And I had kind of an existential crisis. So my question is, like, is it still worth doing machine learning? And in putting together this talk, I also wondered, is it still worth doing machine learning engineering well? And I was pondering these two questions, what to say to a room full of people who might be feeling kind of the same anxieties in working with AI or doing any of these things. So hopefully we'll be able to address all that and solve that in 45 minutes. But until then, let's hold that thought. Let's take a step back and talk about something a little less anxiety-inducing, which is flowers. So when I started thinking about how to put together this talk, I really started thinking about one of the last keynotes I gave, which was at PyData Amsterdam a few years back. Wonderful conference, and they invited me to give a talk in the spring of 2023. So this was right after ChatGPT came out, and the keynote was called Build and Keep Your Context Window. And the idea of it is, even if we have these new pieces of technology, if you know the historical context that you're working in, it makes it much easier to be less surprised and swayed by technological shifts and scared by them. And the main example that I gave at the time was of ChatGPT, which was the top piece of technology that came out. At the time, the ancient time of 3 years ago, ChatGPT was a chat app that was available in a browser, and it had a sidebar and a text box, and that was basically the entire ecosystem. They had an incident where the titles of the chat sessions that you have were switched around with other users. And the reason that was happening because they had a cache invalidation issue, which was really funny to me because it's such a standard, normal engineering problem to have. So you have this, on the one hand, this magic of AI. AGI is going to do everything for you. But at the end of it, they have a real practical issue, which is their caches are invalidated, and you're seeing the titles of other user sessions. And so this talk was really about how the context window, the text that you put into the chat app, and the intention mechanism of the transformers model that powers the chat app are really related to cache, which is really just a hash map, which is a very, very old school and normcore engineering concept. And if you understand that a hash map is also a cache, is also a context window, it makes it much easier to understand that ChatGPT is not magic. And so that's what that talk was about. So while I was in Amsterdam, I had some time to explore the city. Apparently, I was there on like the only 2 days it didn't rain in September, as I was told, and it was really, really nice. And I went to the Rijksmuseum, which is a really, really cool place. It's the National Gallery for Dutch art. You could spend hours and hours and days there. I only had a couple hours there. So of course, I went to see the Night Watch, which is probably the most famous piece of art there by Rembrandt. And when I saw it, it had this kind of like glass enclosure around it. And then it also had some sort of machinery in it. And I'm like, OK, what's going on here? I don't know quite yet. But I kind of put that in the back of my mind. And then I moved on, and I went to PyData. And at PyData, I saw another great talk by Robert Erdman. By the way, I'm going to put all of this on my website, because I know if you read anything I wrote, you know that I usually like to write like a million links. So I'm going to include links to all of this. But I strongly encourage you to check out this talk, because he has a really interesting job in that he was actually examining the night watch. And so what this machine did, as he explained in this talk, is it took really, really high resolution pictures of this painting. So it came really close from this angle, from that angle. And then what he did was he studied the pixels and the resolution. And if you zoom in far enough, you can actually see like the materials and the pigments. And we can learn a lot about how the artist works. And so one part that he zoomed in, which is really dark on this screen, but it's thought that this was Rembrandt in the back of this image, making a cameo. And if you zoom in, maybe you can see this part, the little white of his eye. When you zoom into it, it's fun and interesting to study to understand how he as a master knew that if you paint this little white dot, people are going to understand that it's a reflection in the eye. So something that Robert Erdman talked about was the mystery of mastery. And that's one of the things he was able to study with machine learning as he looked at this painting. And that's something that I wanted to examine too. And one of the other painters who was at the Rijksmuseum, who I actually unfortunately didn't get a chance to see when I was there, was Rachel Roish. And that's really who I'm interested in talking about and thinking about how we can frame our understanding of what it means to do machine learning, what it means to do engineering, data science today. So what did Rachel Roish do? She painted flowers. She painted a lot of flowers. She painted flowers from when she was 15 into her 80s in all sorts of different compositions during the Dutch Golden Age. And why the Dutch Golden Age? What was it? So we kind of know. So the idea behind the Dutch Golden Age was that Spain and the Dutch were in a war for 80 plus years. Then the Dutch finally declared independence, and they started building their own country. And as a result of the fact that the war ended, the economy improved. Then you had the Dutch Empire. They built trading. People's economic condition in general improved over the time. And they also became interested in changing the way that they did art. So with the Spanish influence, a lot of paintings were based in religious imagery or were heavily influenced by Italian masters that really drew ornate things. When the Dutch declared independence, they wanted to draw things from life. They wanted to draw things that were scientific. They wanted to draw things that were accurate and detailed. And these kinds of pictures really depicted the Dutch national character. So they wanted to draw gentlemen smoking and playing backgammon in a tavern, which not a lot of people had done before. They wanted to paint people just ice skating in the winter. And this was during the Little Cold Age. It was 200 years in Europe when it was really, really cold, so everything froze over all the time. So there's a lot of paintings of Dutch people ice skating during this time. They wanted to paint people just having fun, getting rowdy in their own households. And this is one of my favorite artists, by the way. And something that you notice in all of these three paintings is the colors. They're very natural. They're very realistic. They're very normcore colors, right? They're very lifelike. The details are very natural and very precise. And another thing that the Dutch painted during this time was flowers. They painted a lot of flowers. So there are estimates that there were from 5 to 10 million paintings produced during the Dutch Golden Age. We don't know exactly. Let's say there were even 5 million. There were thousands of these flowers painted. Everybody was painting flowers. Why? Because with the rise of the middle class, people wanted to show stuff that was cool and fun in their house. And what was cool and fun? Flowers that were out of season. So especially if you had flowers from a particular painter, and of course there was the tulip mania, which was kind of in the middle of this. But this was even outside of the tulip mania. If you had flowers that were painted in June, but they were in your house in the winter, that was a big flex. And everybody wanted to do a big flex of having really cool flowers in their house. So there arose a whole category of people, and the flowers also had messages. So they had religious messages, they had moralistic messages, life is short, et cetera, et cetera. So if you had some of these in your house, that was very cool. So given the fact that there were so many flower painters, like what was even the point? Why do we want to paint good flowers? Why was Rachel Roish so celebrated? Why did she spend so much time, most of her life, painting and continuously getting better at flowers? Why was it important that she got good? And I asked this question, kind of the same question that we find ourselves asking now, where it's easy and fast to write, more accurately probably generate code. Why is technical excellence still important? So we have tons and tons of different copies of code, which are the same as flower painting. So why is it important to rise above that? And in looking this up, something I found was a NASA guidebook. So like a lot of people, Artemis 2 has been on my mind with the way they orbited the moon. And I've always been a huge NASA geek. And so I found this guide that they created. It was a report that they created in 2012 from previous research that they'd done on failures that they had in NASA. There was, of course, the famous report that they did after the explosion of the shuttle. But then they also had this. And they basically found that ownership comes from hands-on the code and data. And that was the first piece. So they looked at what causes failures at NASA. And they came up with 5 things. They came up with shifting from engineering and hands-on excellence to insight and oversight. Normalization of deviances. So like if something looks weird, they don't say anything about it, just kind of do the work. Lack of critical thinking, reliance on procedures, decentralization of authority, and organization technical complexity. And of course, I'm thinking about this in the context of what it means for us to start generating code as opposed to writing it or doing them both in combination. And the first one is the one that really struck out to me. So there's like a wall of text here. So basically what they found was they shifted away from having engineers in-house to having contractors write code. And what happened as a result of that is that initially the engineers really understood the design. They felt bought in. They felt that they owned it. They had actual experience and they accumulated actual experience. They had hands-on activity. When that went away, a lot of that ownership and independent analysis, test experience, all of that experience went away. And so they found that this caused more errors at NASA. And this is really especially important in the case where you're launching people into space, where I found out like when they were broadcasting the launch of Artemis 2, they said that there was a likelihood that 1 in 30 astronauts on any given mission could die. So this is, for them, this is critical, utmost importance that this doesn't happen again. So why is being good at code, why is mastery, why is striving towards doing good work important? Why is excellence important? Because if you strive for excellence, then that avoids engineering, product, and cost problems from a practical perspective. Secondary, there's a lot of reasons why this is important for us as humans. Just like painting, writing software, developing code, doing analysis is just as much as a craft as it is a hard discipline. It involves a lot of human judgment. It involves having a sense of the data. It involves past experience of doing engineering and code. And so in that, it's just like painting, that it's something that we need to continuously get better at and refine. And thirdly, because wanting to be good at something is just human. A machine will not want to improve unless you tell it to. We inherently want to be good. We look up to people who are experts. We look up to people who are competent. It's fun having someone in a meeting who knows and leads the meeting and knows what they're doing. So we value all of that as people. And so that's important too, that we get to exercise being human in our work. I saw an incident, or maybe I was talking to someone about this meme that you shouldn't yell at chatbots, like you shouldn't call them stupid, because basically they don't care, right? But it denies us something of our humanity. And I think this is in the same vein. Like it's important to want to be good. So, okay, so now I've convinced myself that we need to move towards technical excellence or stay towards technical excellence or still care about the code that we generate. So what made Rachel so good? Why did her paintings sell for 3 times Rembrandt's at one time? Why was she considered one of the most premier flower painters during the Dutch Golden Age? And especially given that she was a woman and a working mom. She had 10 kids, and she was painting throughout this whole time, throughout her whole life. So what are the things that made her technically excellent? So first of all, we can't all copy this part. Her family was really, really fancy. They were high society. So they were really prominent in Amsterdam. A lot of her great uncles were painters. Her dad, pictured here with the creepy skull, was an embalmer, painter, an artist, a physician, Frederick Reusch. And she got a lot of her first intuition for how to look at objects, how to compose objects. Probably a lot of creepy skulls and embalming stuff too. But how to think about nature, scientific inquiry. So really, all of that stuff was imbued in her, both by her dad and her family. And then she did an apprenticeship with William van Aelst. So if you look at his flowers, you can kind of see they look a lot like hers because he was her teacher. And so back in the days, it was common to do apprenticeships. And in fact, for some fields was required, particularly in Amsterdam. So if you wanted to be a painter, you sat with a master painter and you were apprenticed to them and you lived with them for a couple of years. You washed their paint brushes and then you got to the point where you started sketching and then you produced the master work for them to look at. And if they approved that work, then you could then take on your own students. So she apprenticed with him and he's where she learned part of her skill. So she was surrounded. She had an intuition for how to do these things for a long time. The second thing is that she painted flowers for her entire life. So she picked this one thing. She knew she wanted to paint flowers, and she knew she wanted to get good at it. So she started when she was 15, when she was apprenticed. This was one of her earlier compositions. In her earlier compositions, she had backgrounds. And then she moved away from that. And then she sometimes did bees. She did variants. So in the process of doing that for a very long time, she became very skilled at knowing what to change, what to take away, how to go from smaller to bigger things. And she just continuously built her craft. And the third thing is that she was constantly experimenting and remixing. You might be thinking, like, how many images of flowers can I paint? Like, it's all the same. At some point, you run out of flowers. Spoiler alert, you do not run out of flowers. She never ran out of flowers because there's not only different compositions you can make, she experimented with mixing flowers from different times, and she did this by preserving flowers that she dried them, and then she pulled them back out, which is what her dad taught her to do. And then in this one, you can also see there's a cactus. So I don't think there's cactuses that grow in Amsterdam. She got a lot of exotic flowers from what was then the New World, from Africa, from Asia. She was friends with a lot of people in a lot of high places because she was in Amsterdam society and her husband was also a painter. And she somehow convinced them to give her these samples so that she could arrange these flowers. So it's kind of weird because it's like, okay, here's some classical flowers, there's cactus. But it's interesting. And so she constantly experimented, remixed, what if I change this little thing? What if I change this little thing? And so these are the things that over time made her so successful to the point where her paintings sold for a lot and she was in demand. Okay, so how can we be like Rachel? We can't, I don't know, I can't paint flowers, but how can we in our job take on what she's been able to do? And I will give you an example of something that I worked on, and this is Reich Search. This is a side project that I did. And I'll talk a little bit about how I applied some of these things kind of subconsciously, and then I put them together in this talk, to something that I've been working on. So this is Reich Search. It's a semantic search engine where you type in chill dude, and you ostensibly get back images of chill dudes from the Rijksmuseum. And these are all paintings from the Rijksmuseum. And like, you can use your best judgment because recommendations in search can be sometimes vibes. So a man dancing with a dog, yeah, kind of chill dude. A confidential chat, maybe not chill. A man smoking a pipe, chill dude. Okay, so the idea is you type in a phrase that is not an exact text match, is a feeling, and it returns back images of that. And this is a screenshot from localhost 300. Here's another example of I typed in pensive. Philosopher in a study, absolutely pensive. A boy with a golf club, maybe, depends on what he's thinking about doing. He looks like he's up to trouble. Hermit, definitely pensive. So the idea is that you type in a phrase and you get back a feeling that evokes the phrase. Here's another one, flower party. This one was kind of an easy target because if it has flowers in the title or the name, you're going to get back flowers. I was really trying to see if you could get back like a party, so maybe that one is a party, or like the young woman is not having a party on herself. But so you kind of get to this idea. So you see that some of them are kind of good matches, some of them are not yet, but with a lot of tuning could be, depending on the data itself. Okay, so how does this all work? So this is a search engine, just as a reminder or a start. Search engine comes in several forms. Usually when you interact with any given search engine, there's like AI components that you see in the top. But generally these days, many search engines are hybrid search, which involves keyword search, where you search for Apple and it gives you back literally Apple varieties. And there's semantic search, which searches for meaning, where you search for Apple and it gives you iPhone and maybe also Android, depending on what you want people to see or buy or find. There's a lot of different semantic search paths. I didn't even cover all of them, but the one that I work with is dense embeddings, which are representations of these items. So I've been doing semantic search engines in various forms, both for work and for side projects. And this is basically my flower. The semantic search engine is my flower. I try to do it in a lot of different variations just because it's interesting to me to see what we can do. So when I started doing this, I already saw that the Rijksmuseum has a lot of data. And it's amazing because it's all public. It's open access. One of the tools they have is this Art Explorer, which is also already kind of like a semantic search engine. But again, don't let that stop you. So I think David said this in his keynote this morning. Just because there's a ton of stuff happening doesn't mean that you shouldn't do it. You should definitely do whatever projects you want to do. Just because there's a lot out there, do it your way, especially if it's a project that you're doing for yourself. And another thing that I learned from Rachel, as she said, remixing ideas is key. She learned this from other painters. I learned it from Tumblr, where I worked, where they have this reblog button, which was one of the first places in social that had a way that you could share a thought and then riff on that thought with other people. This is pretty standard now, but at the time it was introduced 5 bajillion years ago. It was novel. So, okay, so what did I remix? I remixed some pretty weird stuff. All this stuff is kind of like in my head at any given time. So the first one is embeddings. I'm thinking about embeddings almost all the time. I'm thinking about them right now. What are embeddings? They're vector representations, 3-dimensional dense vector representations of things so that you can compare things to other things, paintings, text, etc. I wrote a pretty big paper about them, like how they work in recommender systems and search systems, etc. So I'm always thinking, there's like 5% of my brain that's thinking about embeddings all the time. The second thing is I was thinking about Redis. So Redis is one of my favorite pieces of software to use because it's very elegant, it's very well written, it's very fast. You can run it locally. It gives you a lot of ownership and it has a great API. And then I think last year, Salvatore Sanfilippo, Anti-Res, who wrote Redis, introduced this new data structure called a vector set, which is explicitly for embeddings. So I'm like, goodness, this is amazing. I'm going to use this, maybe somehow. I didn't do anything with it for like a year. I just tucked it away in my brain. Then another thing I was thinking about is Go, the programming language. So I write a lot of code in Python. Python is my main language. I've also, unfortunately, written code in Java and Scala. But I was thinking, like, what is the successor to Java and Scala? And today it's either Go or Rust. So I was already kind of interested in Go. And then Blue Sky, the social network that became popular a few years back, a lot of their code was open. So I started taking a peek at it. And they have very high throughput. They have very strong structured systems. And I saw that a lot of it was Go. So I'm like, OK, perfect. Maybe that'll give me an excuse to keep going with Go. OK, so first kind of cluster of things I was thinking about is engineering stuff and embeddings. Second stuff is LLMs. Like, this is unescapable. You might not even be able, you don't want to think about it. You have to think about it anyway because you hear about it every day. And it's constantly being told to you, right? So there's Cohere, there's Gemini, there's Qwen, there's Claude. So the way what I'm interested in particularly is both local and open source models. And you can see that in Llama CPP, which is a model you can run, which is an inference framework that you can run local models on, Llama Qwen, etc. So I'm interested in that group. I'm interested in the APIs. And I'm also interested in embedding specific APIs. So these became popular when OpenAI released embedding APIs. Before, people either trained their own models or used pre-generated artifacts for this. But OpenAI was one of the first to really make embeddings available via API, which I hadn't worked with before. So that was swirling around my head. And then the humanities. I love paintings. I love art. I love thinking about how art relates to technology. I think if you think about those two things as separate, it's not as three-dimensional as if you think about them together, because they're the full scope of what we can do as humans. So I'm always interested in art and fruit and all that stuff. So this is what goes on in my head at any given time. It's not all together, and then it's all swirling. And like it was swirling and swirling, and I keep reading about Hugging Face, and then I keep reading about vector sets. And eventually, sometime in the shower, usually it's when I'm not at the computer at all, usually when I'm taking a walk or with my kids or in the shower, an idea comes to me. And so that's when the idea for Break Search came to me. And why did it come to me? Because Rachel built the same thing again and again, so I said that semantic search was my flowers. And this was also the case for me, because I've already built semantic search before. I built Vibrary before. So I built this side project in 2023 called Vibrary. And the idea is, again, like search, you type in a phrase, funny sci-fi or classic drama or something, and you get back books that fit the vibe. So again, just like pictures, but this was with Goodreads data. And so here we have funny sci-fi topics in space with feeling. So like Asimov, I guess, kind of. We have Haruki Murakami on there, I guess, kind of. So this is vibe search for book recommendations without any personalization for you specifically. So I've already done this. And so embeddings, again, my friends, make this possible. So the idea is that you convert it from funny sci-fi or moody classic drama via some algorithm into the embedding space, and then you can compare different concepts. So you can have, instead of dog, bird, and fly, now they're all vectors. And you can see that bird and fly are similar, and dog is not similar. And that's how we get paintings that are similar to other paintings and phrases. So the two-tower architecture is what makes semantic search and a lot of recommendations possible. And the idea is that it looks very, very simple, and it is, just like a flower, but like a flower is also very complex. So the idea is that you have a user or item query, depending on if you're doing search or recommendations. For us, we have chill dudes or happy flowers. Then you encode the query, and you get a query embedding. The same is the case for all your other paintings or your items or your books that you have. You have already encoded those into vectors. And the idea is that then you can do a similarity search on which vector is close to another vector. So if you enter chill dudes, you get back paintings that are similar mathematically to chill dudes. So that's it. But it's also not it at all, because there's a million questions in each of these steps. And the reason that we do it this way is because when we are doing information retrieval, especially when we're serving it to people and it needs to be fast, we need to already have batch embedded our paintings, because we could have 2,000 paintings, we could have 1,000,000 paintings. So we need to make that step where we embed all of that as fast as possible, so that when we embed our query, we only have to embed that query. And then the second thing is we have to do that search step very quickly, which is why we usually do approximate nearest neighbor search, to get the closest things that are closest semantically approximately close to them. So that we can get, when we start with 800, I think Rijksmuseum has 800,000 artifacts in their catalog. The idea is we want to get to the point where we're only offering 10 chill dudes to you if you want to look at them, because you don't want to look at 10,000 things that could be like 10 million things that could be like chill dudes. So I mentioned before that this is like the very simple image of it. This is how it actually looks, not in production, but at least in an academic paper that's close to production. So a lot of companies use these models. So YouTube used to, or still does, use some variation of this for recommendations. So they take into account not only the metadata of the item itself, but also your watch activity, your geography, etc., to offer you videos that are like the video that you clicked on or that you're interested in. And then also, so this is a recommender system. And then also for search, Facebook uses them for search to offer you search results that are relevant, also based on personalization for you. And there's hundreds and hundreds of cases of this. So these systems can get very complicated. You can see they're very different from the one that I drew. But at the base of it, you have two towers, essentially. OK, so that was in theory. How does it work in practice? So again, you have an input query. We have to come up with some embedding model. We have to have all the documents that are also already embedded. And then we do ANN lookup. And thinking about how I wanted to do this, I thought about this post from Dan McFunley. It's often cited. It's called Choose Boring Technology. And the idea is that your company or your project, or myself in this case, has 3 innovation tokens. You can do 3 things that are weird and different or new from anything you've done. If you choose any more, you're going to have a bad time. Because it's going to be too many things to manage at once. People aren't going to know what to do. You're not going to be able to move quickly. So I was thinking about that as like, OK, I'm going to do semantic search again. What should I change? What should I keep different so that I can get to this level of mastery that Rachel got to? Where should we spend our innovation tokens? And for personal projects, but also in work particularly too, we should try to spend them on things that help us grow if we want to get to mastery, if we want to get to competence. So this is kind of how I had looked at doing the project last time in 2023, Vibrary, and then Reich Search in 2026. And so there's a couple things to point out here. So the process is basically the same. We need to collect data, as we always do in machine learning and data science. Always starts with data collection. Unfortunately, you cannot get around that, even with LLMs. Then we need to pick our embedding model. Then we need to index or ingest our embeddings so that we have them to search from. And then we need to build all the serving infrastructure around it. So the first time I did this, I did it with just text data with books. I used Mini LM, I think it was 6 at the time, which is a model that you need to host yourself for inference, and it's a fairly small model. And the embeddings are like 386 dimensions, or 368. And then indexing, I indexed them into Redis into a search index. And then serving, I use Flask. And you can see like the yellow parts that start up. That's where you start to get AI stuff that you could use. In 2020, it's wild to me how different this landscape is. I consider myself like a fairly conservative AI user in that I usually wait 6 months before I try something new because like it either sticks around or it evaporates. And so at the time in 2023, ChatGPT was obviously still big. And then I use Midjourney for some of the images. So what I use ChatGPT for like finding out some stuff about embeddings maybe, and then confirming it with Wikipedia. And then I also was curious about local models. So I tried Mistral B, which was really 7B, which was really big at the time. This time around, I decided to do text and images. So that was harder because multimodal is harder than just text, because now you have to store images, you have to process images, and then you have to embed images. So that's an area that's harder. Then I decided to use this embedding model from Gemini, which is easier in some ways in that you don't have to deal with anything around this model. But then you have to be like, OK, what if Gemini is out? How much does it cost me? This is free on my computer. This costs me cents every time I call it. And then I use vector sets. It's not really indexing because vector sets aren't indexed. They're a freeform native Redis data structure. And then for serving, I used Go. So I basically had, OK, I lied. I had 4 innovation tokens here because I changed this, this, and this. But I also had help because you can see how much more stuff I used. But the way I used it was very different. So for example, for Go, I didn't use Claude Code or GPT-OSS, which is the open local model, to generate Go. I used it to learn about Go itself. And then I also ran the code that they generated by people who write Go every day. And I'm like, is this good? And they're like, kind of. And then they fixed it for me. And so then I got it to help me, but I didn't use it to actually do all of my code generation. For indexing, for vector sets, I think here I used data structures. And then for embedding model, I used Perplexity, which is a RAG-type search engine, to find out which embedding models were available. And what I really like about RAG-type search engines is that they show you the links, so that you can go and verify, and you know where to look for stuff. So they synthesize information, but then you can go and look for it. So I used all this stuff to help me, but I use it more to teach me and to help me get through like the parts that I didn't know as much. Okay. So we do all this stuff, but then the hard part is actually not this part, which is already hard because you have to serve something at low latency. You have to understand the similarity. You have to understand this stuff. The hard part, as we all know in data science and machine learning, is actually getting the data. It's always super, super annoying because we have to re-index the embedding data over and over again to make sure that it makes sense for when we query it. So you query it once, you can see in some of the, what I like to call what I did, just online evaluation. This matches chill dudes, this doesn't match chill dudes. So this doesn't match chill dudes, you have to re-index the data, you have to look at it again. So this is actually a hard part. That comes to the second thing that Rachel taught us, which is that our data experience is a strength. So she grew up surrounded by art culture. She had instincts for how to paint, how to think about things artistically, nature. We as data practitioners have instincts for how to think about data. Even in the new world, even with LLMs, even with generative AI, it's all machine learning. Evaluating them as machine learning, thinking of queries as machine learning, looking at their benchmarks, it's all machine learning and data analysis. And this is one of our strengths as data practitioners. And Rob Pike, who wrote Go, said that if you pick the right data structure for the project that you're looking at, then writing the program and the rest of the code becomes super, super easy. The hard part is actually defining what you want your data to be like. And I found this true to be for Reich Search as well, because we have the image, and then we have all the metadata about the image. And you need both of these so that you get good semantic matching. Fortunately for us, like I said, the Rijksmuseum is wonderful. They have a huge, huge trove of records. 800,000 objects, they have too much data. This is too much data for one person to dig through. 160,000 records, they have all the high resolution photos. And then their data is also accessible via OAI PMH. What is OAI PMH? This was new to me, and it's XML-based protocol over HTTP. So we're typically used to like REST APIs and JSON. This returns XML, and it has this structure that was new to me. And so I used LLMs a lot to help me understand how to navigate this, and then where to read more about this, and how to actually access this data. And Archive also actually works under the same format. So now that I've seen OAI PMH, I see it everywhere, which happens all the time. And so learning how to get this data about the paintings probably took me the most time out of this entire project. Because once you get the data for one record, for one painting, it looks like this. And then you have to figure out, okay, well, which fields do I want? Do I want to pull this? Do I want to pull that? Okay, well, how am I going to pull this entire structure? And this is one area where LLMs are really, really good at, right? Like they can get this structure for you, and they can write code that helps you pull this so you can focus on understanding what it is that you're actually pulling there. Then the other thing is there's lots of categories. Okay, so I want to create a search engine. Which categories do I use out of the 100,000 artifacts that they have? And then what I ended up using was, I believe, Dutch painting in the Golden Age, because it produced good results. It has beautiful images, and it was the easiest to work with to see if semantic search was working or not and verify, just like I did a vibe check just now live. The other thing that helped me was Go structs, which are basically typed collections of data, or a lot like Pydantic classes. And if you structure these correctly, which is what the LLM did help me do, then you can get the rest of your program to ingest and look at the data for how you need to. The cool thing about Go is that you don't always need an LLM for it, because you can just do this. If you have an XML file, you can paste it. There's a website that creates the struct for you. And so like creating the struct was probably one of the most important and time-consuming parts of the project, other than the rest. Once I had this in place, the rest went much, much faster. And the other fun thing is, as you start working with data, the data is not always right. So why is there 2 English titles and 2 Dutch titles, but each one is also English and Dutch? And so once you start really looking at the data and being hands-on, you start seeing stuff like this all the time. I've seen it countless times over my career where like everything looks okay on the surface. As soon as you put your hands on the keyboard and start looking at data, it's like, oh, this is 0. Why is this 0? Why don't I have this field? And so this took me a very long time. This was not fun, part of the project, but it comes with the territory, and we're always going to have to do this, basically. Then there's a lot of other stuff. OK, so let's say you've decided your data, you have your structure, you're ready to ingest the paintings, the images, et cetera, which I didn't even cover. Then you have to pick an embedding model. And so like I mentioned, this is kind of where Perplexity helped, and you can see like they have the links there. There's a lot of choices that go into why you might choose an embedding model. As soon as you choose one that's external, you have to think about inference costs, because it costs every time you hit whoever API. For me, it was important to have multimodal capabilities, because I wanted to embed both images and text. So I had to pick a model that had both. Storage costs can become important. If you are embedding a query every time and it relies on an external service, that service better be up. Like, it can't be like GitHub, which is struggling with its last 9. You always have to be able to hit the embedding service and have it return an embedding so you can get similarity. Ironically, for me, like in looking at all this stuff, it was all fairly similar, and they were all good providers. But I already had a GCP account, so I'm like, oh, OK, you just get an API key there and try it out. And so getting quickly to a demoable state became just as important as all this other stuff for me. Then there's this other piece of indexing, like what kind of embedding index you'll actually create. Luckily, vector sets, it allows you to make some choices, but it does HNSW by default, which is really fast, really good. So I was able to do that. OK, and then you get these results, like, why is this happening? So then you start digging through the data, and a lot of it, so you could have LLMs help you with all this stuff, but then you have to really use the data sense to help you. So where did it help? In learning Go, in formatting data, in all the method level fixes, but it can't help you with the stuff you actually need to be good at, which is understanding that you need a 2-tower model, understanding that you could pick vector sets. Channels, I still don't quite get them in Go, but I will soon. It can't help me with writing this talk, because all that has to come from you. There has to be there has to be friction for it to be good, essentially. Which comes to my last point, which is it takes time to build good things. We're in an enormous rush. We have a lot of pressure to build things quickly, to develop quickly, to generate code quickly. And we need to push back on that, because it takes time to build things that are good. So you can see this painting on the left was what Rachel painted when she was just starting her career. And the one on the right was when she was much, much further along. And you can see like how much more complex the composition is, how there's flowers behind other flowers, how the lighting is different. And it takes a long time to get to that state of mastery where you know exactly what to do that. For her, it took an entire lifetime. And Peter Norvig said the same thing, right? It takes time to teach yourself to become good at software development. And so he wrote this blog post a while ago that you can only really teach yourself programming in 10 years. It takes time from repetition, from mistakes. It has to be something that you, again, feel friction in and do again and again and again. And I found this to be true in my career, especially. So I was going back through my old tweets, which I have archived. This is from 2013, where I was literally just teaching myself Python. I was like, oh, I guess I have to learn Python. And I was doing word count in Python. And I didn't understand how any of this worked. And I was really working. I was really struggling. And then 10 years later, I wrote Vibrary. So Peter Norvig was right. It does take 10 years. And the other thing, it takes time for other people to teach you. So I wrote this post called Alphabet Radio, which comes from a concept from the book Bird by Anne Lamott about writing. The idea is that you have this radio of people who are talking to in your head. And if you have good software developers, good data scientists, good machine learning engineers that you've worked with before, they have these good habits that they kind of stream to you. And every time, just like an apprentice might from William van Aelst in the Dutch Golden Age. And every time you sit down with them, you have these good habits in you, and you really need that form of mentorship. So if you are more senior and you have people you can provide that to, provide it. If you are more junior, ask for it, seek it out. It's really important. And that takes time too. And then it takes time to teach machines. So this is another side project I worked on a long time ago. It's called Gondinsky, like Kandinsky, except generative adversarial network. And the idea is I wanted to teach machine learning model to be able to generate stuff in the style of Kandinsky. As you can see, I had very, very terrible results. And that's because there were only like 200 to 300 paintings that Kandinsky ever did. There's no more that he could have done for me to generate a training set of hundreds of thousands of images, which you need at the time. Right now, Nano Banana can generate you a Kandinsky in like 5 minutes, but how long did it take us to get there? So it takes time to teach machines too. It takes time to figure out where we want to use new techniques. So like the cactus, like where do we want to use agents? Where do we want to use LLMs? We need to be selective. So she didn't put cactuses everywhere. She put them in that one spot for emphasis and where it made sense. This is Anti-Raz again, when he wrote about like how he thinks about automatic programming, which is that programming is automatic and vision is not yet. And it takes time to build your judgment and vision, and what people say like taste is the moat now. It takes time to develop that. Think about what you like, what you don't like, based on projects you've done, based on things that work well, based on things that don't. All that stuff takes a long time. So for me, yes, I built a semantic search engine once I really finally buckled down. It took me like a month and a half. It's still not done, because you can see there's some rough edges around the results. But it took me like a month. But it also took me 10, plus I guess we're 3. So it took me 13 years. It took me a month, or it took me 13 years. And that's true for anything that's important, that's big, that's quality, just like some of the research projects that the other keynote talked about at NVIDIA. Like, it takes time for those to bear fruit. So that's something that we need to keep in mind when we're pressured and pressure ourselves to really produce those results. So with that all in mind, I think now that we've come to the end, I personally think all this stuff still matters, because to produce something good, we need all of this. We need data sense, we need mastery, we need craft, we need time, and we need judgment to do things well. And all of those things still matter, because they produce good results, both in our personal projects and in our work and with our coworkers in our day-to-day working life. Okay, so let's build ourselves some flowers. Thanks.